This video is a review of what we learned in the last video about atoms. We're going to do a little bit of practicing. This is the sort of thing that you could see on a quiz or a test about atoms. So quick review. Using this simulation, atoms have protons and neutrons. They go in the middle of the atom, and that middle part is called the nucleus. Electrons fit on these energy levels on the outside. The first energy level can hold up to 2 electrons. If you add a third electron, now that has to go to the second energy level, and that second energy level can hold up to 8 electrons. In a regular atom element from the periodic table, the number of protons is equal to the number of neutrons. That makes the neutral atom. If the protons and the electrons are not equal, then you get a net charge. So for example, if you have an extra proton, now you have a net charge of +1. That's called a positive ion. If you have more electrons than protons, then you get a net charge of -1, and that is a negative ion. The neutrons, they don't have a charge. They're neutral. They're really just there to provide stability for the nucleus, and you can see that if you don't have enough neutrons in the nucleus, it's unstable. So we add neutrons are part of nuclei so that those atoms become stable. The exact number of neutrons, you can see, isn't always the same, but that's how that works. And then the mass number, protons and neutrons each have a mass of 1 atomic mass unit, 1 AMU. So if you take the number of protons, which this one has 6, and the number of neutrons, this one has 7, if you add those two together, you get the mass number 13. So each proton or neutron adds 1 more to the mass number. Electrons have mass, but that mass is so small that we don't count that in the mass number. We just pretend that it's 0. And that is the basics from the last video. So using this knowledge and a periodic table, what can we learn? I'm going to get a periodic table going on one side of the screen here. This is ptable.com, and let's fill this out. So our first element is hydrogen. What is the element symbol for hydrogen? Well, if we click on hydrogen, we see that hydrogen is the symbol H, capital letter H. And the atomic number for hydrogen is 1. Now the atomic number, that tells us how many protons the element has. So hydrogen, being number 1, has 1 proton. And as I said earlier, we want those protons and electrons to be equal so that the positive charges cancel out the negative charges. So 1 electron in an atom of neutral hydrogen. How many neutrons does an atom of hydrogen have? Well, here's where we get into something that I didn't cover in the last video, which is, let's look at this mass and just round it off. So down here on the periodic table, this is the mass of hydrogen. And the mass of hydrogen is 1.008 AMUs. That's an average. We're going to round that down to 1. Well, we already have 1 AMU from this 1 proton. So in a neutral, normal atom of hydrogen, there are 0 neutrons. 1 AMU from this proton plus 0 from the neutrons gives us a total mass number of 1. Okay, so we use the mass from the periodic table to find that. He, that one is over here. That's helium. So we write the name. I want you to go ahead and pause the video. You have the atomic number for helium. Fill out these 3. How many protons and electrons does helium have? And then use the mass to figure out how many neutrons need to go there. Okay, so I'm assuming you have paused the video and you've actually done this. Don't keep continuing on the video until you've tried it for yourself. Otherwise, you won't learn anything. But here's the answer. Atomic number 2 means an atom of helium has 2 protons. The electrons have to be the same so that the pluses and the minuses cancel each other out. And the neutrons. Well, 2 plus this number has to add up to 4. Okay, the average mass of a helium atom is 4 AMUs. I've got 2 AMUs from protons. That means I need 2 more AMUs from neutrons to get up to a total of 4. If you got it right, pat yourself on the back. Congratulations. If you didn't, that's okay. We have plenty more practice. Again, I want you to pause the video, try this one for magnesium, and I will come back and give you the answer when you're done. Okay, in 3, 2, 1. You've paused the video. You've tried to figure this out. Hopefully you found that magnesium is right here. Be careful. This is the one that's atomic number 12. There's also manganese, which is number 25. Sounds similar, but it's a different element. So magnesium is number 12. That's Mg. If it has atomic number 12, that means 12 protons, 12 electrons, and 24.3, we'll round that off to 24. So 12 AMUs from the protons, here's my scratch paper, plus something from the neutrons has to give us 24 total. 12 plus 12 is 24. So again, these numbers are the same on this one. Keep going. Pause your video. Try to do the entire rest of this chart if you can. When you get done with that and you unpause it, I'm going to go through all the answers at once. So 3, 2, 1, we're back. You've spent some time trying this out. Let's see how many you got right. Next row, atomic number 88 is down here. That is radium. This is a famous element because Marie Curie worked on this. Very radioactive element. It's so radioactive that it glows. Atomic number 88 means 88 protons and 88 electrons. Mass is 226. So 88 plus something has to add up to 226. That's going to be 126 plus 12 is 138, I believe. Yep, I got that right. 138. These atoms get big sometimes, right? 88 protons, 138 neutrons. That's just a nucleus. Think how many rings it'll take to get 88 electrons going all the way around that. Much bigger than the drawings that we started with. All right, find the element with 16 protons. Well, that's going to be number 16, which is sulfur, because protons and the atomic number are the same. That means we have 16 electrons. Check the mass. It's 32. 16 plus 16 gives us 32. And hopefully you're noticing a pattern that these smaller elements, the neutrons and the protons, tend to be the same. But once the elements get real big, then the protons and the neutrons start separating. We start to need more neutrons with the bigger elements in order to keep that nucleus stable. Remember, if it's unstable, things start shaking all over and it becomes radioactive. Okay. Let's keep going. Protons 53, that's going to be atomic number 53. Looks like that's iodine. Capital I is the symbol. This element is used in first aid as a disinfecting covering for open wounds. Mass is 126.9, so I'm going to round that off to 127. I need 53 plus something to give me 127. That's going to be 47 plus 27 is 74, I believe. Did I get that right? Yes, I did. 74 neutrons plus 53 protons gives us that total mass. Which is the element with 83 electrons? Well, remember, protons and electrons are the same. So that's going to be 83. Atomic number is the number of protons, so that's going to be 83. So we'll just find number 83. Looks like it's bismuth. This element is in Pepto-Bismol. Helps you with heartburn. 208.98 rounds up to 209. So So we've got 83 protons plus something has to give us 209. That's going to be 126, I believe. Yep. 126 neutrons. Of course, you can use a calculator to do that. You don't have to do it in your head. Same sort of question down here. 29 electrons. That's 29 negative charges. Means we have to have 29 positive charges to balance it out. The number of protons is the same as the atomic number, so this is number 29. 29 is copper. Copper is not CO, it's Cu. Isn't that interesting? Notice there is a CO, but that's cobalt. Mass of copper is 63.5. That rounds up to 64. So we're going to take 29 protons plus however many neutrons gives us 64. That's going to be 35 neutrons. Last one, symbol is Cl. You have to dig until you find it. It's right here. It's chlorine. Chlorine is number 17, so 17 protons, 17 electrons, and the mass is 35.4. That means we keep 35 here. 17 plus 18 gives us 35 total. And that's it. I hope this makes sense.